So I think one of the very first questions we need to answer is what is anything as code, right? What is having anything codified even by us, right? So first we should define what code is. And in our context, when it comes to the SOC, we usually mean either something like a data structure or a language that describes a state. What you see there is DSL, that stands for domain specific language. We describe a state, or we can mean code in a traditional sense, right? Like an automation or a script or something like that. Those are usually centered around automation. The magical part about a state is that it's declarative. You are declaring to the system that you would like it to move toward that state. This creates something pretty special. It creates a source of truth for us. Any deviation from that truth we would consider to be erroneous. This is a source of truth, and you can use those principles of software engineering to help you define where that source of truth lives. So this also has a few side effects. This allows you to produce an audit trail, who committed what and when, and an accountability, right? Who performed those changes and when they started to arise in the system. So that kind of has a side effect of allowing you to monitor the system as it moves along. This also gives us a place to apply the principles of software engineering to operations. That means things like approvals, reviews, version control, right? If something goes wrong, you roll back a version. Other systematic advantages also apply here. So any operation you might use in something like Git or other VCS, you can apply this to SOC operations. So what we're trying to do is essentially create a system where infrastructure as code meets security operations. We do this because our data needs grow. Our customers' needs grow. Our response needs grow. As those needs grow, our SOCs have to evolve to be more efficient.